Okay, this video is going to be for our section 6 of our week 4's lab, talking about tangential planes. This is going to be our example question. As you can see here, this is what it looks like up on the course website itself. I'm just going to move over here now to the drawing. As you can see, the drawing, basically what it's asking us is to identify, or basically to draw in the plane that is going to be touching externally to this sphere and to this cone. So as you can see here, it's basically a pictorial of what we're completing. Now the reason why this is an external one is because it's travelling like so off the side of the two objects, rather than travelling in between the two objects and touching off the side of both of them. So for this first one, for the external one, what we're going to need to do is develop a cone over the sphere so that we can draw this plane that's going to be touching basically off of the cone itself as well as the sphere. So I have a bit of a model here to represent our cone. As you can see it here in elevation, and you can imagine it here in plan. Now I also have a sphere, which you can imagine is it here in elevation and below here in our plan. Now what we're going to need to do to basically draw this plane so that's in there is we're going to need to develop a cone which has the same angle as this one over here, so the same angle as this over our sphere. So basically what we're doing is we're getting a cone, the same angle, dropping it over the sphere itself like so, and sitting it down on top of it. So we're going to be developing a sphere like that, or sorry, like this over the top of it, and then it's going to look like this in our plan. Now when doing that, what we can basically do is get the angle that we want to lie down our plane on to basically touch off the side of our cone and the side of our sphere. So if we start doing that now on this drawing, what we're going to do first of all is draw our cone, which is going to sit over top of the sphere in elevation. So all I'm going to do is get a parallel line to the side of this cone to keep the same angle, and bring it over till it touch tangentially off of the sphere itself. So I'll use my sliding set squares. Bring it over, line up as best I can. Draw it where it touches tangentially off, extend up and down to hit the XY line. What you do then is extend the center of the sphere like so to go up to find the apex of this this basically cylinder that's going to be, or this cone, sorry, that's going to be sitting over top of the sphere. Now I'm not going to bother drawing on the other side of it because all I really need is this half to represent it below here. So all I need to do then is extend the side of my sphere across like so in plan, drop down the side to basically draw that base circle of this cone below here in plan. Now remember, this is all construction. Like so. Now what I can do is I can find my horizontal trace here. So all I need to do is draw a line that's tangential to both this circle and this circle. So if I line it up like so, extend my line, and now I have my horizontal trace HT, and now I need to find it above here in my elevation. And to do that, all I need to do is carry a line basically any one of these points. Let's say I'll just take the apex of either one of the cones, so I'll just take this one, take it parallel to that horizontal trace till it hits the XY line like so. Then I'd have to do is take that perpendicularly up from the XY line straight up, and then take the apex of my cone to that across, extend this line over a small bit. Now what I can do is I can draw a point from here through that point that we've now located upwards, and that is going to be our vertical trace. So our VTH, so our vertical trace and our horizontal trace. Now we've found our two traces of our plane. So that's basically over here in our pictorial. If I was to draw that in, this would be the point V, this would be T, and this would be H. As you can see, that's represented over here in our drafted drawing. Now all we need to do is find our point of contact, or our line of contact, between the cone and the sphere and the plane. Okay, so I know that there's going to be a line of contact between the cone here and this plane, and it's going to be perpendicular to this line, to our horizontal trace. Because you can imagine here, your pictorial, it would be this line of contact right there, like that. So where this sheet basically touches off of that cone. Like so. That's our line of contact. And now for our point contact, where it's going to be touching off the sphere, all you need to do is basically draw a line like so from the center of your sphere, perpendicular again to your HD, so your horizontal trace. Then what you can do is locate basically the point of contact where this, how could you say, this cone is touching off of the sphere here that we created before. To do that, all you need to do is draw basically a perpendicular line from this point back to the line here. So if I do that, perpendicular with it, slide it back, where it makes contact here, drop that down like so, it hits around there, rotate it till it intersects the line that we've drawn, like so. And now the point will be very close to being on exterior line here, the most extreme line, but it's just outside it, and that is going to be our point contact, just inside it. And then to find that in elevation, both the line of contact and the point of contact, just take it up. So we'll make a generator above here, draw it up like that, join that back up to the apex. At this point, all you have to do is carry it directly up, and then take the point here parallel with the XY line across. Where they intersect will be the point in elevation. So there's the point in elevation. And And that is the question completed. You found the point of contact in elevation, the point of contact in plan, and you find the line of contact here on the cone in elevation, the line of contact in plan, as well as you have your trace, so your vertical trace and your horizontal trace.